afternoon, everyone. Can you hear me?
Yes, sir.
Okay, thank you. Oh, yeah, thank you, Tian Wei. Okay, so today we will discuss a past year question. But first of all, just let you know that between RME, RMH, and RE, the question three questions will be similar. Only one question is different. Okay, so for RME, RMH, you will have one question for exergy. And for REE, you will have four questions, all on renewable energy, and may have some theory part on the exergy. Okay, that's why I think we will take REE paper as a reference. Okay, so for RME and RMH, you can try to do the exergy question in the past year. If you need any further explanation, you can approach me personally. Okay, by email or by WhatsApp also can. Okay, so let's download a few past year questions. You always can go to the I have sent my screen. Okay, you always can go to the eprint.uc. Okay, you just type eprint DARC, then it should appear. This is the library resources lah. Okay, and then type in the courses that you want. Let's say I type renewable energy. Okay, and then maybe you start from the latest one. Aware of the code now, but some is not for engineering and technology. You can see that, okay, this is the latest BGE 4723. You start from this one. You have to log in using the user your student account, of course. Okay, so this is a May 2021 examination. May 2021, okay. So let's have a look on this question. There is a 4 question over here. We can discuss together. Okay, let's start. Maybe you can look. Maybe I'll give you 1 minute to download the paper. Let me set up the record. Okay, first question, determine the altitude angle alpha and azimuth angle z of the sun at Perth, Australia. So you are given the coordinate at 4 p.m. local time on 3rd of June 2021, and given the time zone at Perth is GMT plus 8. Okay, so for this case, I think we don't need to complete the entire calculation. I'll just show you how to do it. So first, I think you have to apply equation to find alpha and z. You have the proper equation, but what you have to not aware of is this. Okay, for the latitude, whether it's south or north. Okay, and then for the longitude, whether it is east or west. If north, you have to use positive in all the calculation. If it is south, you have to use negative for all the calculation. Same thing for the longitude, you have to use positive for east and negative for west. I think this is the only part that you will make mistake always. The rest, I think, should be quite okay. Okay. Then we move to the second question. As an engineer of this is one company, Sierra Power Contracting LLC, you are required to build a 10 kilowatt photovoltaic solar panel system, which is the stationary, on the flat rooftop of the Outspace Tower at Dubai. And you are given the coordinate of this tower. What is the ideal solar panel facing direction? Explain your answer. What do you think? We discuss lah, don't just I just talk and then you just listen. Try to give your opinion. You have to face the north, south, east, or west. Face south, okay? Yeah, if you face south, I think you understand why we need to face south. because the tower is located at the north hemisphere. Okay, so most of the case, in order to get most of the sunlight, the panel must face to the south. We won't face our panel to the east or west. Okay, we will always face to the solar node, which is at the middle, and we just face to the north or face to the south only. Okay, so this one you have to face south because location is located at the north hemisphere. So you can explain the answer lah, why you want to face south. Okay, to get the most sunlight, you have to face to the south, when the location at the north hemisphere. Okay, and now of course you have to also state that the solar irradiance during the solar is maximum, so that you won't choose to face the east or west. Okay, so it means that two things: north or south, which one you choose, and east or west, which one you choose, or you don't want to choose any of them, you want at the middle. Okay, this is referred to the solar node. Then you get 6 marks. North and south, you explain, you get 3 marks, and then east or west, you explain, you want to face the solar node, you get another 3 marks. Okay. Okay, what is the recommended tilt angle for the solar panel? Explain your answer. So for this case, now you need to have a angle. Just now you just refer to a direction, but what angle would be the best? So for this case, you should refer to the lecture note. Okay, I think there is somewhere in the lecture note. Which chapter? I can't remember. I think the last part, maybe. Okay, this is a calculation to calculate what angle would be the best. Okay, this one, the optimum tilt angle for solar panel. Then you can always apply the equation. So for this case, the location is at the latitude is 25.22, 25.22. So your latitude is between 25 to 50. So you have to use the latitude 25.22 multiply 0.76 and plus 3.1. Okay, and then you will get the answer at what tilt angle will be the maximum. Okay. Not difficult, huh? Okay, then move to the second question. Describe the standard test condition under which the PV module performance is measured. Okay, what is the standard test condition for photovoltaic module performance? Normally, you have three criteria. One is the solar irradiance of 1000 watt per square meter. Second, the plate temperature of 25 degrees Celsius. And the third, the AM of 1.5, the AMS coefficient of 1.5. But you can see that this question only gives you 4 marks. If you have 3 points, definitely not able to divide by 4. Okay, so you always give if you cannot remember, you always give the 2 point, which is very important, which is the solar irradiance of 1000 watt per square meter, and this temperature plate 25 degrees Celsius. The AM, the AMS coefficient is normally optional. I check some of the specification not really indicate the AM. So we consider as an optional. But you remember right off and 3 criteria for this standard test condition. This test is to get a standard to test the PV module performance, so that entire world they will use the same standard. So the panel made from China, made from US, they are using the same standard, something like ISO. Okay. Actual operating condition of PV module may change. Assess the possible change from the SDC and explain how this change will affect the module performance. Okay, so first, SDC have 2 different criteria, temperature and solar irradiance. So first, possible change from the SDC. First, solar irradiance can be lower than 1000 watt per square meter, depends on the location of the sun. Okay. So that, and also the atmospheric condition. So you have to explain why it will reduce the solar irradiance compared to the standard gas condition. So this is the first thing. Secondly, explain how this will affect the module performance. So when the solar irradiance drop, what will drop? The efficiency will not drop, but the power output will drop linearly with the decrease of the solar irradiance. Okay, and then second parameter is temperature. When the panel is exposed to the sunlight for a long duration, the temperature of the plate will increase above 25 degrees Celsius. Can be up to 60 degrees Celsius in Malaysia. Then when temperature increase, efficiency will drop. Okay, you have to explain how it affect the module performance. Not only say, yeah, temperature will affect the efficiency. So temperature will affect the performance. But what do you mean by performance? Is it refer to the power output, or refer to the efficiency, or maybe something else? Okay, so make it more detailed. So try to write more. You have 2 hours and 30 minutes to answer 4 questions. So you should have enough time to write all your answers. Okay. Can follow 4 marks for this?
Can, sir.
Okay, good. Okay, then next one, part C. So this, you have the solar path of Georgetown. Okay, solar path and Georgetown and Kinabalu at the bottom. And you have to determine the sunset time in local time on the 31st of August for both locations, and discuss the difference in sunset time in Kota Kinabalu and Georgetown. 5 marks. Okay, so 21st of August. Okay, the red line refer to the 21st of August. Maybe we complete this first one for Georgetown Penang. So what time is the sunset in local time? You can refer to this graph and then come up with your answer. Okay, so from here you can see that where is it? Can you see the time over here? 08, 09, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19.
Can,
okay.
sir.
Thank you. Okay, so sunset is over here. Okay, I need to check left side or right hand side. So what is the value of this? So here is 7 p.m. already. So at sunset maybe 7:30. Okay, so I can expect Georgetown will have the sunset at 7:30. Then we move to the second one, next one, which is Kota Kinabalu, Sabah. And same thing, this is 6 p.m. And I would guess the sunset will be around 6:30 p.m. This is just my estimation based on the graph. Okay, so you give the answer. The sunset for Georgetown is 7:30 and the sunset for Kota Kinabalu is 6:30 p.m. And discuss what is the difference. Okay, so what you can see here is the sunset time in Kota Kinabalu is actually much earlier in local time than Georgetown. Because both locations, so this one you have to explain why Kota Kinabalu will have the earlier local time sunset compared to Georgetown. Not because of you have to explain in 2 ways. One, these 2 locations share the same time zone, which is +8. Both are Malaysia, so we use the same time zone. But the longitude of Kota Kinabalu is far to the east. You see that? So one, you have to talk about the longitude. One, you have to talk about the time zone. They share in the time zone. You cannot say that, because Kota Kinabalu have the longitude far to the east compared to Georgetown, then so what? It won't give you an earlier sunset just because of the far to the east of the longitude. Okay, you have to always compare the time zone. Okay, doesn't mean that the far to the east that the location will have the earlier sunset in the local time. We have to check the time zone as well. Okay, so 2 points over here. One is to check the time zone. Second is the longitude is far to the east. Yeah, so this is how we answer this lah. I just give you a tactic lah how to answer the question. Okay, number 2. Determine the solar noon in local time on the 21st of August for both locations. Solar noon, local time. So maybe you look on this, Georgetown. Solar noon is when the azimuth angle equal to 0. So at the middle. Okay, so this is at the middle. So if I refer to the local time, this one is 30, 1 p.m., 40, 2 p.m. So somehow it's closer to 13. Maybe I can estimate 1 to 5 p.m. Okay. And then for the Kota Kinabalu, this one is 12, this one 13. So maybe I can estimate maybe 12:20 p.m. No calculation is needed. Just check how you read the graph. Okay, this is a tactic over here. When this kind of question come out, what if you don't know how to read the graph? You always can use a calculation, but the information may be insufficient. Okay, for example, this one, let's say I have date. The date is 21st of August, and I know the location. You can see that, location. Location given, gives you the coordinate. So your coordinate, you have the date. Of course, you can determine when the solar node and sunset using the equation. You can always do that to check your answer, or just to find the answer and then explain with your own word. Okay. So it's something like tactic lah, because I won't ask you to draw it out in the graph. You have to explain based on the graph, but you always can support it with equation. Okay, number 3, determine the day length on 31st of December 2021 for both locations. So 2021 for both locations, do we have the line over here? If no, then we have to refer to the equation. Okay, you can see that we do not have the line for 21st of December. But what is the problem of this? Okay, you can see this is the north, south is the earth. Middle line is the equator. So we know that the sun will move from east to west, sorry, north to south. So when the sun is at the north, here we have June 21st. And when it's the bottom, south hemisphere, we have the December 21st. So that December 21st is actually the location where the sun is furthest away from both location Georgetown and Kota Kinabalu. Okay, so it means that this location, when December 21st, this date, the altitude angle at solar node will be minimum. Okay, so let's say it look on Georgetown, which point have the minimum solar altitude angle at solar node? This point. Okay, and then if you refer to the graph, the sun will pass through the start of that location as well. So that this is the start. So yes, my estimation is correct. So this is the minimum value. This is a location when 21st of December. Okay, so you have to find the line, this point, and this point, in order to calculate the day length. You can see that we have the line over here, the timeline 19. This curve is 19, and this curve is 8. So you say that the sunrise over here, sunrise at the right hand side. Okay, wait a minute. Yes, I see something. Okay, you see, this one I think the timeline is in opposite direction. Why? You can see that this one is negative. What's the meaning of the negative azimuth angle? Negative azimuth angle refer to the morning. Okay, and then positive azimuth angle refer to the afternoon. Okay, so it means that this morning, this afternoon, but because of the timeline is follow his, so we follow timeline. Here is before 7, sorry, after 7 p.m. Just after maybe 7:10 p.m. sunset. And this one, it will be, this one's 8, before 8, maybe 7:30. So from here, sunrise is 7:30, sunset is 7 p.m. So you minus this, you will get the day length for both location. Okay, so based on this, based on the altitude angle, we determine the line, which line represent December 21st. Okay, just ask if you have any question. And then the last one is the determine the date of sub-solar point in Georgetown. Sub-solar point in Georgetown is mean that alpha equal to 90 degree at solar noon. So which point we have the alpha equal to 90 degree at solar noon? So this one you have to refer to the graph. So it can be at this one 80, so it can be at this point, or can be at this point. Okay, or this point. So you always can use the equation to calculate this sub-solar point. How to find it? You have to use the equation. Okay, let's go back to the equation. Okay, this is the equation for alpha. So you want to set alpha equal to 0. Alpha equal to 90 because you want to get the sub-solar point. And then L is the latitude, it's a constant value, should be given. And then H is the hour angle, which is at solar noon, hour angle equal to 0. So you need to use this equation and find alpha. Find the delta. Once you have the delta, you can start into the equation for delta to find the, to find the date. So if you know the date, then you already know when is the date you have the sub-solar point at Georgetown. Okay, this one definitely you have to use equation because the graph here is do not have enough information. Okay, so here you find the sub-solar point. For Georgetown only, no need to find for Kota Kinabalu. Okay. Okay, first two questions are more on calculation, then we try to go for the next one. Then this a bit theory. Explain the concept of anaerobic digestion, where we call it as a decomposition to convert biomass resources into electricity. Okay, this one should be not difficult. So you to explain the entire process of this anaerobic digestion. So this anaerobic digestion is actually a biological process which the microorganism break down the biomass fuels or biodegradable material in the absence of oxygen. So remember the keyword absence of the oxygen. And then you also have to talk about the final product, which is referred to the methane gas. Okay, I think if open book exam, this one definitely is 3 marks for you. Okay, it's in somewhere in the lecture note. You have to prepare your own lecture note. Okay, so concept now. Yes, now any question? Not acceptable now. Okay, so maybe I just let you know a little bit rules about the exam. Okay, you are not allowed to communicate with your friend. It means that you are not allowed to use WhatsApp or Facebook to text your friend, so that you are not allowed to use keyboard and mouse during the exam. You have to, everything, you have to write it on the paper. So if you want to refer to the note, then it must be the hard copy note. It's open book, but not from internet. Okay, I remember that previous exam, we let the student to have open book, but it's not the open book. They open internet, they ask question in the internet, but not ask from a friend, but ask from the expert outside. They pay for account, and then they ask for the answer from the expert. Then of course everyone will score very good result. Okay, so we will try to reduce the this cheating case. In case you found that your answer is very similar, or you found it online, copy online, then you may need to sit for another exam, a special exam, or you will need to be interviewed after the exam. Just ask you to reproduce the answer, something like this. Okay, so don't try to cheat during the exam, and you are not allowed to refer to online resources. Only hard copy resources is allowed. Can be book, can be lecture note. Okay, and now is it okay? Okay, then move to the second part. Palm oil mill entrance POMB is wastewater generated from palm oil milling activity. It has high organic content and is a potential resources for biogas production. However, POMB is commonly treated using open ponding system, comply with the government regulation without extracting the biomass. Then I need your thinking, your own thinking. Why biomass is not captured as a fuel for this case POMB? It's not having anywhere in the text. But if you understand the concept of POMB, then you should be able to answer this. What do you think? Why is not captured as a fused POMB? Remember that POMB is come from the wastewater for palm oil milling. It's used to sterilize, used to soften the oil palm fruit. And this wastewater which contain a lot of organism and also oil. Some oil come from this oil palm. Why is it not used as a fuel? We know that POMB have a lot of potential to convert to methane gas, to capture the gases from the POMB to be the methane gas, and can be used as a fuel. But why not many company doing this? Maybe you can share your answer. What do you think? Not worth for profit. Yeah, okay. Don't worry, but you have to be more detailed. Why not worth for profit? Yes. First we can talk about maybe low energy density. Okay, PUMB, yes, it's a lot of potential, but the energy density is very low. And then maybe high cost of investment. The bonding, you have to use a close bonding, so it's maybe very costly. So high cost of investment, including the plant construction. Okay, the final idea is definitely go to the not worth for profit, but you have to further explain why it's not very worth for the profit, not worth for the investment. And what else? Maybe you can talk about lack of required knowledge. We don't have much expertise, technical expertise in this area. Or maybe you can say that we have better renewable energy in the palm oil milling system activity. For example, we have the empty fruit bar can be used for burning and produce electricity directly. Why we need to take care of this POMB which have a low energy density? Okay, we should take care about the competitor. What actually POMB have? What competitor that POMB have? Which is the biomass. come from the palm oil extraction, something like empty fruit branch. Okay. Yes, Munjun, this one, I get what you mean. It means that it's not effective lah, because the energy content is low. Then the energy cost to process is take more than the energy generated from it. This one I think is quite subjective lah, because you say that it must be lower than that. Something like I'm not really sure about this. Okay, but I think definitely some of them able to make some profit from it, but not all of them. Okay. So discuss 3 reasons. This one is something like you need to give a justification correctly. Okay, 3 points. I will tell you how many points you need. So this one 3 points. So and then low energy density lah. We have a better alternate renewable energy resources at the same location. But then you have the BOMB, definitely you have the empty fruit branch, because both are the product of the palm oil production, palm oil process. Okay, so and then high cost lah, lack of knowledge lah, lack of technical expertise lah. This is all the point that you can explain. Okay. Then next, a combined cycle geothermal power plant. Then you have to know what is combined cycle geothermal power plant. Use both gas and steam turbine to produce up to 15% of more electricity from the same fuels than the traditional simple cycle plant. With the help of a schematic diagram, briefly explain the working principle of the combined cycle geothermal power plant. So this one they ask for schematic diagram. So you must draw the diagram. Of course, you can copy from lecture note. Nothing wrong. And then explain the entire process. The steam comes from the ground and then split into the gas and water, and then you have to explain the entire process lah. Okay, but must draw the diagram. Okay, then you get the 8 marks. Still not difficult if it's open book. If closed book exam, then maybe you have to remember quite a number of things. Normally, the student able to score for this kind of theory question, but when they ask for the opinion, then normally the student fail to explain in detail. Okay. Okay, then question number 4. Wind energy is one of the most attractive renewable energy sources, and it's growing largely in the current global energy context. For a given location, a wind speed of 10 meters. Okay, this question is actually after this exam I put into the lecture note as an example. So this we have the different wind speed, okay, at different height. So we can use the equation to find the wind speed at the height of 90 meters. I think we don't need to further explain here, as we already covered in the example in the lecture. And then second one, a wind turbine has a 1 megawatt rated. I think the 3 of this question we actually already included in the example. So first is about the different height. So different height, we have the different wind speed. And then next we have the different temperature. So temperature will affect the density of the air. So as we know that wind energy comes from the kinetic energy, which is 1/2 mv squared. So if you change the density, supposedly you're able to change the total energy in the field. So lower the temperature to be higher or more impactful the wind. So just use the equation to calculate this. And then number 3, figure Q4 show the change of the air density and specific volume with altitude. Estimate the change of the rated relative to the sea level condition. This one is about, again, air density with the height, with the altitude. So when we getting a higher altitude, then the density of the air will be getting lesser. So we give you the graph over here, and then you have to check that what if this 1 megawatt turbine is used in 2000 meter altitude above the sea. So how much the power will drop? Okay. Okay, then this question. This is something like again ask for your opinion. Hydroelectric energy composes a significant portion of Malaysia energy grid. It is a low emission, renewable form of energy. Would you recommend building more hydroelectric power plant to achieve Malaysia target of 20% renewable energy in its generation mix by 2025? What do you think? We want to use more renewable energy in the future, and our target is 50% by 2025. So this question, you can say yes or you can say no. I do not recommend to use hydroelectric power to achieve the target, and to give the reason. Why not recommend this? First, you have to give three disadvantages of this hydroelectric power compared to other type of renewable energy. Okay, so what is the disadvantage of hydropower? You can talk about it's not green lah, it reduces oxygen generation lah, you have the impact to the river or marine ecosystem lah. You can say that it has a flood risk lah, dams collapse lah, high initial cost lah, any three of them, and further explain. Okay, this is the if you answer no, I don't want to use this. If you answer yes, I want to use hydropower to achieve this target, then give three supporting points. Maybe hydropower is very reliable, emission free, or maybe the output can adjust accordingly to the demand, and you can store the energy. Can be as a big fish farming, can be a recreational park, or something like this. You can have a lot of answers to write. It's okay, but don't stand at the middle. I mean that I ask whether you recommend or not. You say partially recommend, partially not. Don't like that. So you have to stand at your own decision. Yes, I recommend, or not. No, I not recommend. And give a supporting one. Okay. This is a bit. Last question is a bit critical. Cavitation. So this one is included some part of your other knowledge from you learn from other subject. Cavitation is one of the common problems that causing damage to the hydraulic turbine. I think I explained this somewhere in the lecture, I guess. Propose a method to avoid cavitation in a reaction type hydraulic turbine. So what's mean by cavitation? Hydraulic turbine is actually used to generate power from water or from the fluid. But when it's reached a certain pressure, okay, when the pressure drops too much, this water will actually convert to gas. Okay, that's why we call cavitation. If we have the bubble from the blade attached to the blade, and this definitely will damage the hydraulic turbine because the hydraulic turbine may not have the balanced pressure of it. Some of them is water, which have high pressure. Some of them is air, which has much lower pressure. So it's for long term, definitely will shorten the life of the hydraulic turbine. So how am I going to reduce the impact of this cavitation? Okay, so maybe I can use polish the blade so that it will be smoother. So when it's smoother, it won't create the low pressure zone that create cavitation. Okay, maybe I don't run the turbine runner at the very high speed, just at the design speed. Remember that when we run at the very high speed, it will cause the stop, SDALR, cause somewhere we have the pressure different or maybe a turbulent flow. And this will affect this cavitation as well. So you have to run at the desired speed only, but not more than that. Okay, this is what we can do. Or maybe we can change the material of this hydraulic turbine. I can use a stainless steel runner, stainless steel blade of the turbine, which not able to create more cavitation, because stainless steel first is stronger. Secondly, because surface of the stainless steel is actually smoother. So when it's smoother, it's less resistant, the tendency to create the cavitation will be lesser. So just have to propose one method and explain. Okay, 5 marks for this. Okay, any question on this? Not difficult, huh? Okay, good. Then you try the next one. So what else? Or maybe we should VGEE 4723. Okay, not much we have. Okay, because previously it's not using this code, this is a new code. So later we just try renewable energy. Maybe you try this. September 2020 examination. This is also the online exam. Okay, question number 1. A solar thermal collector collects heat by absorbing sunlight. Propose 3 methods of how the efficiency of the non-concentrating solar collector can be improved. Non-concentrating solar collector can be improved. So how you want to improve this? You cannot put another few plate and then focus all the sunlight into one point. That's already become concentrating solar collector. So for this case, you have to think about how to do it. Maybe I can improve it by reducing the heat loss by convection. So this can be done by using glazing or cover, or I can use a better glazing, which have the higher transmissibility. Okay, I can use a better fluid, which have the higher heat capacity. I can use the plate, I can use the pipe, which have the higher thermal conductivity. And of course, after you state, I want to use the glass with a higher transmissibility. Then you have to explain why. Because the higher transmissibility glass will allow more sunlight to reach the panel. And then here I can improve the output. Okay, so you explain one by one. So there's a lot of method. And then this one doesn't think that it's still non-concentrating, but it didn't say that it's stationary. So you also can say that, yeah, I can install a tracking system so that the panel is always face to the sunlight. Okay, so a lot of answer you can give. This just is 3, but remember only 2 marks for each of them. So don't talk too much also lah. It's just afraid you have no enough time to cover everything. Okay, so this is September examination. Okay, then second one. A solar thermal collector at what azimuth angle sun tracking solar panel at Tokyo should point to get. Okay, this one is where you need to point your panel to get most of the sunlight. So for this case, you need to find the azimuth angle, altitude angle, and then find the tilt angle for the solar panel. Okay, 10 marks. So it means that you need to calculate the convert local time to local solar time. Okay, and then you already can, based on the local solar time, you get the hour angle, and then you already can find the alpha and z. 10 marks. Very long, but not difficult. Okay. Okay, then figure Q1 show the solar path diagram of the New Delhi. Determine the azimuth angle at 11 a.m. local time on 20th of April. This one. Okay, the azimuth angle at 11 a.m. local time on 20 April. So 20 April is 9/3. We find line 3, and then 11 a.m. 11 a.m. is this line. So the problem is now we have 2 points. So which point is the correct point? Okay, you maybe start from here. Point line 7, December. December, January, February, March, April. The question asks for April. Okay, so April is the point at the right hand side. So this point. So you can check the azimuth angle at here. So maybe around -60 degree. So this is how we calculate this azimuth angle on this date and this time. Secondly, the day length in hour on 22nd of December. 22nd of December and day length. So you start from sunrise to sunset for line 7. Number 3, the local time of solar noon on 32nd of June. Local time on solar noon, 32nd of July. Sorry, 32nd of July. Where is 32nd of July? Line 2. So which point is it? I know that solar noon is at the middle. Line 2 middle should be over here. So I have the time here is June. So this is July. 1 p.m. July. June, July. 1 p.m. 12 p.m. July. So I can say that the local time should be maybe 12:50 p.m. around that line. So everything you just refer to the sun path diagram over here. Okay, so next one, question 2. According to these Albert Betts, no turbine can capture more than 59.3% of the kinetic energy of the wind, independent of the design of the wind turbine. Briefly explain the concept. Okay, even your system is the best, you also won't capture more than 59.3% of the kinetic energy in the wind. This is because according to this Betts, the air after it passes through the turbine must have at least a liter of the kinetic energy to flow away. Okay, so this one we can call it as a principle of conservation of mass and momentum of the airstream. It must have the continuous flowing. It cannot stop. So you have to explain if energy coming from wind movement extract fully. So what happened? The wind speed afterward drop to 0. Okay, so that all the wind will stack over there. So the keyword is actually principle of conservation and of mass and momentum. You explain this and you get and further explain, you get the full marks for this. Okay. Then look on to question B. Which turbine is more cost effective to use if the location has a wind speed of 10 meters per second? Okay, you can see that turbine A and turbine B, they have different rated wind speed. Rated wind speed is mean that at 12 meters per second, this turbine will give you the rated power of 2.0 megawatt. And same thing, at the wind speed of 50 meters per second, the rated power is 2.5 megawatt. Okay, now you want to calculate the power output at 10 meters per second. And then we know that the wind speed, the power output is directly proportional to velocity q. I think we cover this in the example as well. Okay, then you calculate for both and then check which is actually more cost effective. Okay, and then other than that, discuss 3 other considerations other than wind speed and cost for the wind farm site selection. Other than wind speed and cost, what else do you need to consider as an investor or anything? You have to consider the impact to the society, impact to the environment, pollution, and what else? Everything. or maybe distant from the residential area, distant from the substation, so that you can connect to the grid easily, or maybe alternative land use option for the candidate, maybe public acceptance, can the surrounding resident can accept you have this kind of the wind turbine over here, and impact to the wildlife, and also the supply and demand, of course. If this location already have enough power, why you need to build a power plant over here? Okay. But normally, when you want to make the resident accept your sorry, when you want to make the resident accept your proposal to build a wind turbine, they should get something, they should get some benefit by me. So the benefit can be in terms of profit. Maybe you can share profit with them. You use their land, or you disturb them, so you pay a little bit, share a little bit profit with them, so they were okay with that. Or secondly is their location is lack of power. They do not have enough power supply, and then you build a wind turbine over there. So even there are some noisy come from turbine, I think they will accept it because you supply energy to them. Okay, they must get some benefit, they only will accept, or else they will definitely will find some excuse to complain you. Okay, so remember, selling for profit or provide some benefit. For example, I supply. Okay, then next one, the tip speed ratio lambda. Okay, this one maybe you not really pay attention to this. The tip speed ratio lambda for wind turbine is an important parameter used in wind turbine design. Explain how the tip speed ratio is used in wind turbine design. So for this case, when we do the turbine design, this tip speed ratio is tip speed ratio is mean that tip speed ratio, the speed of tip of the blade, and also the beat speed. We call it as a tip speed ratio. Okay, this is used by the wind turbine designer to properly match the optimum blade to the generator. You want the blade to rotate at the same speed at the generator need. Okay, so you have to adjust properly so that they can have the proper mesh. First, you can save the or reduce the size of the gear. Okay, so this is actually very important to select the blade to mesh with the generator. What I say is the speed what speed you need for the generator, and then you design accordingly to the tip speed ratio. It will give you how much rotational speed you have. Okay, and again, that remember that tip speed ratio will affect the angle of attack. At a certain angle of attack, you will get the maximum efficiency. So based on the tip speed ratio, you can design so that your wind turbine have the maximum efficiency. Okay. Number 3, biomass gasification is a process that converts organic solid carbonaceous material into carbon monoxide, hydrogen, and carbon dioxide. The resulting gas mixture is called the syngas, and syngas is the word I use in the lecture, but somewhere you can see they call it as a producer gas, but it means the same thing. It's called syngas, and it's a fuse. Briefly describe the process of biomass gasification. Here you have 10 marks on this. Okay, so the process, so we have driving, pyrolysis, combustion, and reduction. And if can, you can draw out the process, and in each of the process, what actually is doing: drive, combustion, pyrolysis, and reduction. We still repeat, so you can just go through it. And then next one, discuss 3 advantages of syngas compared to the conventional solid biomass fuse. Maybe you can share your answer, because a very short answer. What is the advantage of syngas compared to conventional solid biomass? First, we covered fast combustion. Fast combustion, the word fast is actually quite subjective. What do you mean by fast over here? Easy to handle, yes, modular. Okay, yes, modular, totally accept. Is easy to transfer. Yes, easy to handle. Yes. High caloric value, no. I don't think you have a high caloric value compared to solid biomass. You have the lower caloric value because remember that when we convert from solid biomass to gas, you burn some of it. So the amount of caloric value should be lower, but you remove the water content and it can have better air fuse mixture because both are the gas. Air is a gas, fuse is also a gas. So when you have an better air fuse mixture, you also can reach the higher temperature. Okay, it also can be interchangeable with the natural gas, correct? But fast combustion, I don't think so. I don't really understand what I mean by fast combustion here, but maybe it just refer to that it can mix well with the air and fuse, then it can burn in a more reliable way. Okay, there's a lot. But mainly it can reach the higher temperature, which the biomass cannot reach, the solid biomass cannot reach. What else? I think something like this, like we have more than 3 long. Okay, what compressible and possible to have high energy density? Yes. To me, yes, if you compress it, it's possible to have the high energy density. But it's a per unit input, you should have, I mean that now you have 100 joule of biomass, solid biomass. You convert to syngas. I think maybe you left only 60 or 70 joule. 30 or 40% of the energy already been wasted. Can you see the meaning here? So that actually it won't have too much energy inside already. Unless you compress, then the other story. But again, you waste some of the energy during the conversion. You use some of the calorie value already for the same amount of input. Okay. Okay. Then what else? I think okay lah. This one we have enough already. Then number 3, discuss 2 disadvantages of biofuels in power generation compared to fossil fuels. This one's very simple. What do you think? Why I don't use biomass fuels, but I use fossil fuels? So biomass fuels, this one you can say is very low calorie value, low heating value, high water content, low thermal efficiency, because this cannot be reached high temperature. So these are points that we can discuss when we deal with the biomass. Okay, and then you want to be further, you can talk about you do not have very pure substance and the composition is not consistent. This all will cause a lot of effect in the power plant efficiency. Okay, number B, burning either fossil fuels or biofuels release carbon dioxide, a greenhouse gas to the environment. Explain why the burning of biomass is said to be less harmful to the environment. Okay, we study the biomass. Why we say it is less harmful to the environment? Anyone? What is the advantage of using biomass compared to fossil fuels in terms of the environment? Carbon neutral, yes, this is always the key point of the biomass. It's carbon neutral. What else? It can be recycled. It can be recycled. I think we don't have any. Okay lah. I think Wei Shen, you mean recycle is mean the recycle of carbon. Okay, cycle of carbon. Organic. The organic is then how organic impact to the environment? How is better to the environment? So better you read the question twice before you answer normally. I know that yes, biomass is organic and fossil fuels not, but then how you link to the environment? Again, Yao Ding, you say burning biomass is cheaper. Then how you link to the environment? But I don't think burning biomass is cheaper. It's definitely more expensive to process. Yes, less garbage, okay. You can reduce the waste. You burn the biomass, you reduce the waste. So good for environment, you reduce the waste and carbon neutral. And you want to say renewable. Okay, you want to say renewable, you have to explain better in a better way. How is linked to the environment? It's renewable so that I do not need to find or dig more fossil fuels. Then okay lah, you of course you when you harvest the fossil fuels, actually you respect for environment. You dig coal, you have dig the oil from the seabed, which may cause an accident or what, and then leakage or what, something like this. But it's not only renewable. You should link to the environment. Okay. Now the gas come from the combustion biomass less harmful than fossil fuels. Then you have to explain what kind of gas come from biomass is less harmful than fossil fuels. If you compare with the coal, I guess okay. I compare to oil, petrol, I don't think so. Okay, to me, less dependent on fossil fuels, less emission. But for the environment impact, it's still the same. Although it's less dependent, but for the environment, we still release the same amount of emission. Okay, so the keyword still have to go back to the carbon neutral and reduce the waste. These two are always the main two criteria for environment. Okay, but renewable again you can use, but you have to explain further. Not only because biomass is renewable, you're not really link it to the environment. Okay, so this kind of question easy to answer but difficult to score. So remember, link to the environment. Okay, maybe we will stop here today and continue on Wednesday. Okay, any other question? Can Long have to focus all because it's already open book exam. I cannot give you much on that. Because I think nothing you need to remember, is it? You have to understand only, not really need to remember. Chun Ming, your coursework mark I will release on Wednesday. I think I have done the marking and I have leave you the comment for your assignment as well. You can check your Google Classroom. I have write a comment for you. If no comments mean that very good lah. Not much comment on that. Wednesday I will release the mark. Okay. I will upload lah. I will upload as soon as possible. Maybe tonight lah. Now I will upload tonight. Once ready, I will upload. Okay. Thank you everyone and see you on Wednesday.
Thank you, sir.
Okay. Thank you.